All right, we're going to get started in just a couple minutes. Stream's current bitrate lower than the recommended bitrate. Well, what do we do about that? Okay. I can stop streaming and start again. But I think we'll just leave that for next time. Hopefully things look okay. It looks better than yesterday. I think I'm streaming on a higher resolution. All right, so where did we leave off? We left off making a list of functions that downloaded a bunch of Texas voter data for us. We were then exploring which libraries to open the shapefiles, join the voter data, and perhaps do some plotting of voter data by district or county or some other interesting subdivision. And once we can do that, we can start looking at cool stuff like who voted for who and why, and demographic stuff. Maybe even go looking for new data and try and find correlates of voting patterns. That'll be really fun. So to get started now, we have to pick a visualization tool, some packages that'll help us read the shapefiles. And I think we were going to use one called SF, and I was installing it from compilation. We're not going to do that today. I think we have it installed, so let's just like we do. So let's not be silly. Let's definitely include our library. And we're also going to use our standard tidyverse library. Helps us do all kinds of cool data stuff in a neat, concise, clean way. And what else? Well, for that, I think that comes with, yes, it comes with ggplot2, which we're going to use for plotting. And now I'm just going to open up the SFR simple feature. Yeah. Package vignette. Let's just start with the one. All right. So features are basically like a certain collection of coordinates on a grid system. It's pretty complicated. You can have a lot of different kinds of grid systems. You could have longitude and latitude. You could have easting and northing. Your grid could be rectangular, or it could be on a surface. Naturally, the Earth is on a surface. It's not a rectangle. And so then we have to talk about what type of projection to use to plot it in our 2D surface world on our computers. And this package is going to do a lot of that for us. It's going to do a lot of the interpolation for us, which is really what's nice about using GIS data, is that the geometric interpolation from surface to rectangle coordinate system is done automatically. You can see there are a lot of different types of geometries that are going to be saved. You can have a point. Point data basically is characterized as, a single coordinate. You have a line string, a sequence of points. This doesn't have to be a straight line like in geometry. The points can be just simply, it says here, non-intersecting line P. A polygon, a collection of points that form a closed, non-self-intersecting ring. It's just a shape, right? You have multi-point, multi-string, multi-polygon. Lots of cool hierarchies here. geometry collection. Set of geometries of any type, except geometry collection. So it's not recursive. For additional geometry, rarer geometry, it says, circular string, curved type of line string, arc. Okay. Compound curve has both curved and linear segments. And curve polygon, so these are just defined as arced surfaces. Triangle. Triangulated irregular network is a polyhedral surface consisting of triangle patches. And then here it talks a little bit of coordinate systems. Coordinates can only be placed on Earth's surface when their coordinate reference system is known. But we're talking about projection. This may be a spheroid CRS, such as WGS 84. That's very commonly used. A projected two-dimensional Cartesian CRS, such as a UTM zone or web merge. Very common projection. Most my age saw many Mercator projections used in the classroom. They're probably still very common in textbooks and things. Makes Greenland look as big as Africa, notably. Now, that isn't to say that it's just bad, right? A lot of people sort of equate the Mercator projection bad. Not bad, it just serves a purpose. And that purpose is not to represent land area equitably. Or a CRS in 3 dimensions, or including time. M coordinates need a attribute reference system, measurement. Right. Attributes are typically stored in a data frame. This is really nice because data frames are easy to work with, and we can use tidyverse to inspect them and analyze them. Very convenient. Geometries are not single value. They're put in a list column, list of length equal to the number of records. So we'll be able to dig into those lists if we need to find out information of particular elements of the data frame, why something isn't visualizing how we want it to, or maybe why it's not joining properly, or even just inspecting those elements for interesting things that we can plot. If we use models to create new things to visualize, it's likely that they'll be stored in similar types of elements within these data frames or within data frames that retain some of that structure. And we'll want to look into those. So it's very nice that it's in a data frame. So the 3 classes used to represent simple features are SF, which is the table, this data frame, which contains the geometries and attributes. SFC, the list column with the geometries for each feature, is composed of SFG, the actual. So the structure is kind of nested, and the actual, say, points or multi-points or polygons are stored at a separate layer. They're sort of deep down. Going into an example, and lists a lot of features for a given polygon here, and all that's going to be stored. In this case, it's an Esri shape file, which is cool because I think we have some of them. So already we're getting confirmation that this is going to work with what we need. So it says, as we usually do not work with geometries of single simple features, but with data sets consisting of sets of features with attributes, the two are put together in SF object. The following command reads the NC, this is just an example, the NC dataset from a file that is contained in the SF package. So st underscore read, how we open this. And it's using rather specific way of accessing that file. I wonder why it uses system.file instead of just another way to do it might be to store the file name as a separate variable, and then That's interesting. I wonder if this is necessary. Anyway, we'll do it that way because note that users will not use system file but give a file name directly. Interesting. So this is some, they're using this because it's stored within the package itself and they have to like dig into the package to get it. But give a file name directly. So that's what we're going to do. And that shapefiles consist of more than one file, all with identical base name, which reside in the same directory. That's how our data is stored. The short report printed gives the file name, the driver, mentions that there are 100 features and 14 features. This object is of class SF. So here it's a data frame, or meaning it extends and is a data frame, but with single list column with geometries, which is held in the column name geometry. Right? If we print the 3 features, we see their attribute values in an abridged version of the geometry using the print method, print function, I should say. And this type of object, this class SF, does have specific print methods associated with the function. You can see that here. It prints out the geometry type, the dimensions, the bounding box, the geodetic CRS, which stands for Coordinate Reference System, and we have the first 3 features. Don't know really what these are. They're not enough information given in the file name or in the column names. Burr 74, SID 74, measurements of some kind, perhaps. Okay, but that's not too important for our purpose. Mostly, we're going to want to read in our data. So let's see if we can do that. Take a sip of our coffee. So, okay, so we'll need to find our shapefiles. Not there. They're in here. Start with 2024. So this is our path. Copy as path. You can do that in Windows by right-clicking while you hold Shift. So that's a handy little shortcut. I want to copy as path. So shape 2024 path. And how else did they do that? So ST-read. I'm going to look up exactly how to use ST-read here. So it has a lot of options depending on if you need to specifically set certain things. I'm hoping we don't have to do that. Data source name, layer name. So I'm hoping we don't have to do that. Interestingly, we can pass a query directly. Okay. The example they give here is also in that file path, and I guess what we're going to say is shape 2024. Going to need, I guess it's So, what should we call this? Shapefile or something like SF 2024. ST, right? ST read. And we're going to do file path shape 2020 path shape. All right. So this is just going to take our two variable names and parse it into a file path, and hopefully that's all we need to do here. Now this may or may. Okay, so Windows likes or backslashes and R like forwards. That. And it looks like it worked. All right, so what did we get here? Reading layer from data source using driver Esri shapefile, simple feature collection with 9,000 features and 8. They're polygons, and they're using this NAD 1983 Lambert conformal conic projection, which I've seen before, so it's just a standard. Nice. All right, let's go back to the documentation. We can try to print. Let's do that. Sure, it's not going to give us too much more information, but why not, right? SF 2024. Don't give a there. So here is, we have our county, a color, whatever that is, VTD, so we can use that to voting tabulation district to join on other data. County key, VTD key, county VTD. All right, so county VTD, it looks like it's just a concatenation between county key and VTD. Shape area, maybe in square meters or square miles or something, I'm not sure. It seems quite big to be square miles. Shape length, geometry. This looks like it could be easting and northing coordinates. So this would be like meters then. Possibly. All right. See here, they're listed in longitude and latitude. Do we get a bounding box on ours? Perhaps not. Might not have a bounding box. Oh, it does. X min, Y min. These almost certainly are easting and northing, which would mean that this is square meter. All right. In the output, we see this stuff. All right, and we do see that stuff. Great. Ours are stored as polygons and not multi-polygons, which is interesting. Convenient, some might say. You might think to yourself, well, of course they're polygons. These are like voting districts, which are just like an area, which is true. And that can be stored as a polygonal shape. And that's almost always true, but you get multi-polygons in situations like Hawaii, for example, where your voting district might be, or your state is across multiple regions, the islands. And so you have a multi-polygon that designates different individual regions that are part of the same context, the same shape. The islands of Hawaii are a single state, so the geometry would be saved as a multi-polygon. But I guess we don't have that in Texas, at least in terms of voting districts. And that's actually not to say that there aren't some multi-polygons in there somewhere at the top of the data set, where we see the polygon. All right. Here we provide a list of methods They are printed as well-known text. Well-known text can be transformed back into our native object. So we can see that the geometry, the polygon, in this case line string, can be decomposed into a list of points. And that's literally how the data is stored within R, is as this list of points. And that can further be decoded into binary, which is probably how this is like how it's stored in memory, which is interesting. So, theoretically, we could write manually a line string or polygon that had the form of these, pairs, and it would create an object, and we could provide like easting and northern coordinates and create our very own polygon. And it wouldn't even be that big of a deal. It wouldn't be that hard. Just saved as plain text. Okay, it's a double. Okay, so it has double precision, which just means that at extreme values of integers, there might, there could be some rounding issues, basically. But in general, we're not going to be at that level of, we're not really going to be doing analysis down to the meter. So I don't think it's going to affect us too much. We end up doing math that relies on precision in meters. We have to be aware that there could be some rounding issues. None of that seems really relevant to what we're doing. We have this list of methods, and we have a lot of cool stuff here. You can determine if things intersect, you can combine polygons, you can rotate them, you can do a lot of stuff. And it's all handled in this package, so we don't have to write any code, if we want to determine if two polygons are intersecting, or perhaps take their unions, or whatever. So if we want to create sets of polygons that all have the same properties, we might use something like stunion, and it's going to be very easy for us to work with those kinds of objects because of the SF package tools. All right. It's possible to create a data frame object with geometry list columns that are not of class SF by using the asDataFrame method. Okay, this could be important once we're trying to plot things, or maybe join the data frame with objects from another class in another package. Sometimes you have to convert directly to a data frame to do things in a sort of generic data fashion. A lot of our generic data method generic functions are not going to know how to handle objects of class SF, but they will know how to handle objects of class data frames. So if we need to scrub our geometries of their SF designation, we can just use asDataFrame. No big deal. And it tells us here that they are no longer register which column is the geometry list column, so we lose that. They no longer have a plot method by default, so we could actually plot our object right now and see what we get. It should probably look like the shape of Texas, with all of the voting districts intact. And it lacks all other dedicated methods. So once we, of course, convert our SF class object into a data frame class object, we can't use any of the SF dedicated methods. Now we might be able to convert it back, particularly if it has all the necessary columns still, if we don't get rid of the geometries and things like that. But typically we're going to want to only do those conversions one direction, so that we don't lose any information.
All right, now we're talking more about this well-known text idea. And here is the example data. NC now becomes clear. It's North Carolina. Okay,
let's look at our data. Let's plot our data and see how it is. So here we printed one element of NC geom, and you can see that it's in this well-known text format, and it is a list of coordinate pairs. Those are going to be every little nook and cranny on this county map of North Carolina is going to be one of those coordinates, right? So the plotting method is literally connecting the dots. It's playing connect the dots with all of these coordinates in a specific order, probably. Goes clockwise around the county or something like that. So they have to be ordered properly. And once, if they were out of order, you could imagine that it would just be connecting the dots, from corner to corner, which wouldn't be what we want. We want to go around the outer perimeter. So the order does matter in these well-known text formats. Okay, because it consists of multi-polygons in the form of multi-polygon, poly 1, poly 2, where poly 1 might consist of an exterior ring and 0 or more interior, as of x1, hole 1, hole 2. So it's designating how you have to specify the multi-polygon shape. Sets of coordinates belong to a single polygon are held together with parentheses. So here you go, where chords is a comma-separated set of coordinates of a ring. Right. And here it's showing you some of the polygons which have exterior rings, multi-polygon sets here. You can see here, right? Like these outer barriers, the islands and the outer banks of North Carolina are discontinuous, and so that's the multi-polygon. All right, but let's look at our data. Plot shape. Control-Alt-I to generate another code. Really nice to work in these, notebook style environments when you're just exploring data for the first time. We can see our output, it's up there. We don't have to worry about rerunning scripts over and over again. It's just convenient. I'm sure everybody uses these. All right, it's taking some time to plot, but then it has to connect the dots, right? We're connecting the dots in 9,000 different shapes. All these geometries have to be drawn. But it's interesting to note that plotting this actually does take some time. So if we're going to create some kind of visualization tool, we're going to have to take into account that rendering this plot is not instantaneous. It takes quite a bit of time. So we can already start thinking about what we could do to help accelerate the plotting, right? Why is it taking so long? Well, it's taking so long because it's plotting 9,712 features. That is 9,712 voting tabulation districts. Of course, the simplest way I can think of to one window is done, but the other's not. Interesting. The simplest way I can think of to speed up the plotting is to do county level plotting. So there's not 9,000 counties. Oh, interesting. It did each one multiple times, actually, one for each feature, perhaps. Yes. So this is interesting, too. The default plotting method plots each feature. And there we have it, though. There we have each 8 times. So we did 9,700 times 8. What is that? Let's do some mental math. 7,200. 7,700 times 8 is another
or 72,000, another 5,600, so it's like almost 8,000. Or 80,000, of course, right? Because 8 is almost 10,000. Simple math. All right. Let's go here. I'd like to render this again in a bigger window just to expand it, but I also don't want to plot the whole thing again. So let's see. Plot SF. Let's see if we can specify only plot a given feature. As XY. Let's see. Objects of class SF, Y is ignored, okay. Freeze, log Z. And these are important things, but not exactly what I'm looking for. What I'm looking for is some way to only plot one of these maps. I only want to plot a single feature. Now I could truncate the file. I could just select, say, county, and we could just plot the counties. But I'd like if there was a automatic way to do that. Manipulate plotting order, add a custom legend, plotting device. The features are plotted in order. See examples for when a different order is wanted, but I only want to do limited sets of the features. Maybe our example file has some. And we had multiple features in this file as well. We had, what did we have? We had these, all these, birth rate, sudden infant, this is birth and infant mortality data. I think this is births, sudden infant death syndrome, yeah, non-white births maybe. They like to use epidemiological data for these examples because it's all just free. Let's see. Coordinate system transform. I don't really care about that. What I care about is plotting W, 1, columns 2, 7. So here they've collected the multi-polygons with this little statement, which have length greater than 1. This is the plotting method. We're setting up the parameters for the graphic device. W, 1. Let's see if we use a similar syntax here, what the first element in this data is. Maybe we can borrow from them. One feature, one. So if I do like this, yeah, it would be county. But I don't want county, I want, say, VTD, which would be 1, 2, 3. All right, so let's try to plot this instead. And I'm going to comment this out so I don't actually plot the 80,000 voting districts all over. This should be a bit faster. Yay. All right.
Look at this. Beautiful map of Texas with all the voting districts. I'm going to run it over here so that I can look at it in the plot viewer and expand it. I really want to see these cool little details. You know, basically it looks like a population map of Texas. How come it didn't pop up? Oh, we're still waiting. There we go. A little slow because every time I change the window size, it has to redraw. A lot of lines. Nope. When I maximize, it redraws again. All things to consider. That's pretty cool, man. So we can see all the voting districts of Texas here. When we get into the urban areas, man, they're really small, aren't they? The population density of Texas is just super cool. Very cool to just look at this. You can even get some sense of certain structures, certain geological features. Like, what is this area right here? That's so cool. You know? Kind of looks like a caldera. Maybe it is. I don't know. Maybe that's a ancient Cretaceous caldera. Caldera is a eruption crater. That would be a truly massive caldera. Could you imagine eruption the size of Dallas, the whole Dallas-Fort Worth area? Oof, epic. Start a new ice age. I have no idea what that feature is, though. It just has a weird round shape, doesn't it? We can see here's the Austin area, western Travis County, out here into the Marble Falls, Johnson City regions, sort of in this area, to Burnett, Marble Falls, Johnson City down here somewhere. See Blanco County. Is that arrowhead look? Very cool. Very cool county shape. And it's composed of several voting districts. 1, 2, 3, 4, 5, maybe 6. It looks like it could be a tiny one in there. All right. Voting districts of Texas visualized. Well, this is just the first step, right? Like, we actually want to look at the data, the voting data for certain elections. But this is just so mesmerizing. I could almost just look at this for for hours. Just so many cool features to look at. You can see the little oil towns of West Texas, Lubbock, Amarillo, San Angelo probably over here, Odessa maybe. Not sure what these ones are. Iran is out here somewhere. And we have, I think this is like Wichita Falls maybe. Richardson, Texas maybe. Not sure. Texarkana over here. College Station. Waco. Gallon, Brownsville area. Del Rio. Eagle Pass in this Del Rio. I can never remember. Corpus Christi. Very cool. Very cool. Beaumont, and Orange. Okay, there we go. Voting districts of Texas. Never looked at that as one map before. Very cool. All right, we could look at it color-coded by area. You can see in this map right here that the shape area is the scale, and not surprisingly, the big voting districts are in West Texas, where there are very few people out in the Big Bend area. And the length, shape length, I'm assuming that's the perimeter. It's going to be, of course, highly correlated with area. Color, I'm not really sure what the color feature is. Looks go values between 1 and 6, something like that. Interesting. And we could look at it by county as well. And of course, we would see the broadly the same structures here. It would just be, let's see if we plot by county. Actually, we can do a little thing here and see how easy it is to manipulate these data. So if we do, say, let's do county SF 2024. Let's say we do something like SF 2024. Group by T. And summarize districts. So what we're doing here is, if this is not going to work. I wanted to group all of these into counties and then plot the counties, but the shape files don't work that way, do they? So in order to do this, I'm going to have to run an operation on this geometry column. And the geometry column, I'm going to have to basically union all of the existing geometries that are part of the county. I wonder if I can do this with a summarize operation. Something like geometry equals STN. I mean, if this worked, that would be amazing. But I don't think it's going to work. Well, oh. Interesting. Interesting. So, been do. All right. Well, we'll have to read on and see how to do operations. Okay, mixed geometry, simple feature geometry. All geometry inherent from simple geometry, but also have a type and a dimension. Okay, colors are mostly polygons. Looks like you can kind of R-bind them, which is interesting. Multi-point, line string, multi-line string. It all makes sense, right? Polygon, multi-polygon, geometry collection. Very nice. Reading and writing, that's all good. Driver-specific operations. Okay, so if we run into trouble reading data. It could be because it's trying to read it using the wrong driver, and we can manually specify the driver, but I hope we don't have to deal with this. GDAL provides, so, okay. Spatial databases. Coordinate system. I don't really want to worry about transforming coordinates. But if we download data from other coordinate systems, we'll have to transform them into the existing coordinate system, and before we can join those data. So that could be important when we're trying to add other data. This is going to be perhaps important even as we try to add just voting totals. Okay. So now we're talking about some of the geometrical operations, like intersects, disjoint. Okay. Intersects, disjoint, touches, crosses within, contains, overlaps, yada yada yada. Return matrices. Okay. So if we ask using st-intersects whether North Carolina 1 through 5 intersect with North Carolina 1 through 4, we get a matrix back with all of those comparisons. The 1 intersects with 1 and 2. 2 intersects with 1 and 2 and 3. 3 intersects with 2 and 3. Say intersects with, now of course the diagonal will always be true, right? Because it intersects with itself. I guess if you say sparse equals true, you probably lose some of that information. You don't need to duplicate all the comparisons. Buffer, boundary, convex hull. So you can draw shapes around, bounding shapes around geometries, right? Adding borders and things using these. They return new geometry. ST union NC. So here we've unioned all of the shapes in the North Carolina file to create one map of North Carolina. And here's an example of how to intersect two polygons and color it. Very cool. So this is sort of getting at what we want to do. We want to union all the counties. So how attributes relate to geometry. This will be important. Standard documents about simple features are very detailed about the geometric aspects of features, but say nothing about attributes except that their values should be understood in another reference system. But there's more to it. For example, for variables like air temperature, interpolation usually makes sense. For others like human body temperature, it doesn't. The difference is that air temperature is a field which continues between centers, where human body temperature is an object property that doesn't extend beyond the body. Spatial statistics, bodies would be called a point pattern. Their temperature, the point marks. For geometries that have non-zero size, like voting distance, attribute values may refer to every subgeometry or may summarize the geometry. For example, a state's population density summarizes the whole state and is not a meaningful estimate of population density for a given point inside that state without the context of the state. On the other hand, land use or geological maps give polygons with constant land use or geology. Every point inside that polygon is of that class. Some properties are spatially extensive, that attributes would be summed up when two geometries merge. Population, example, voting total. Other properties are spatially intensive, the average population density. Simple feature objects of class SF have an aggregate attribute, AGR, that points to the attribute geometry relationship, how attributes relate to their geometry. It can be defined at creation time. Okay. So constant, a variable has a constant value at every location over a spatial. And you aggregate values are summary values over the geometry. Population density, dominant land use. Identity values identify the geometry that refer to the whole of this and only this geometry. Voting total. If we're talking about voting district, voting total is a constant, isn't it? I feel like it is. The number of the district is an identity. And if we summed the voting totals over the counties, that would be an average. But that doesn't help me figure out what the operation will be if I want to aggregate over a specific. So the county is an identity, right? The county itself. And I want to aggregate over an identity and total vote totals, get county level vote totals. Say that's one thing we would want to do. Okay, so we made it through the first vignette and it didn't answer a question. And it doesn't have a link directly to the second vignette. How frustrating. So we go back. And we go to the second package. Using ST read and write. This isn't going to be helpful. Manipulating simple feature. Oh, this we actually read. Oh, wait, no. I thought. Okay, this looks like it could be helpful. ST polygon. Check if it's valid. Other line geometries are simple. Okay. Distance. Intersects. Yeah, that's all fine. Disjoint, touches. Yeah, that's all fine too. Union. I get that. But I actually want to run a union operation across, let's just look up this ST union and see if it maybe allows us to pass a variable which specifies how we by feature. It does. Okay, so if we do something like county and we say ST union, and we want to find F4 by feature equal to do. What happens? Not compatible with request. Type character. feature equals true. F union. I think I have to pass it like this. County. X and Y. Not quite right. Geometry for union. If I feature is true, geometry is. Oh, it's not exactly what I want. Okay, we're gonna ask ChatGPT. Hello. I'm using RPack SF. I have a data set, 9,000 approximately 9,000 features. How many attributes? 8. I want to use STUnion to aggregate, join to union geometries across one of the feeds. How can I do this? It is with dplyr group by. Okay. Group by your field. This is almost exactly what I tried to do. Okay, but it didn't work for me. Let's just try again. Okay, so we have SF 2024, and it says group by county. I think maybe capital. And then summarize ST, what does it call it? It calls it geometry. Yeah. ST. Yeah, it doesn't like it. Why not? Apply to object class. Oh, I have to say yes. Fine. Okay, it's working. I must have not used capitals. I've said lowercase cnt. I could scroll up, but we're learning. Okay. So now, if we plot, let's do this first. Print county. $154 feet. That sounds about right. And look, data is right there. So this is exciting. Plot county. Much faster. Boom! Look at that. The county map of Texas. Beautiful. This is coming along nicely, isn't it? All right. Fantastic. Well, go AFK. So enjoy this beautiful map of Texas. And right back. Map of Texas. Excellent. Really great. So,
have return. Same thing. I mean, there's no one in the chat, but it'd be nice to have the chat window open. Not sure how to do that exactly. Let's see. To see there are no chat. All right. So, map of Texas, county level map of Texas. Not as interesting as the voting district map of Texas. You don't get to see cool features. You see some cool rivers and stuff. Colorado River, Lower Colorado, Upper Colorado. Blah, blah, blah. All right. So we've did this cool operation where we unioned all the counties into new polygons. And if we check the class of our new object, we can see it's still class SF. It's also still class data frame. So using this dplyr group by summarize operation, it did not change the data type, which is good, convenient. But it inherited these two classes, which is interesting. All right. You can see that when we printed it, seemed to lose, or something happened to the fidelity of the print object. But we still have all the information. So that's cool. All right. So we have our map of Texas, our shapefile for 2024. We have all our voting districts. And so we should be able to start trying to join the actual voting data onto those voting districts. So let's try to read voting data. Our voting data is stored in downloads. And we can look at 2024 general, might be a good place to start. And these are all different elections, I believe. So if I open this one, this is going to be the presidential election. And the election is the election number is the first one, and the suffix here is the office. I have a list of offices. You know, now that I look at this, I sort of regret not... Oh, where is the list of offices? I have it somewhere. I sort of regret not... Here it is. Suffixing the office name like in order to get the office now, I have to do this kind of weird operation where I read the data and then reference this table. I guess this is in JSON format. And try and do some kind of a lookup where like office ID and then pull out the office, like office type, what? Office name is what it is. No, it's not in JSON, it's a flat file. It's just that this is saved as some kind of weird string. Okay. So we can read these offices, and maybe we'll need to do that just so that we don't drive ourselves crazy trying to. Okay, we'll do that after. Let's just look at number 1, which is the voting results. Okay. So general election 2020. Try read. General election. Same here. If but we have to take these 2 forward slashes like R preferred. And G 510 underscore table file file. Let's see what. Okay. Say head. Type that out over and over. And we didn't get it. Rebuild. How is it? This. So, you can see the vote totals here. Nice to see that Jill Stein got fewer votes than the write-in candidates. And we have the county voter district and the VTD key. Interestingly, this and this is not. So you can see here, this has been prefixed by number of zeros. Look at the tail. So this kind of data stuff is actually pretty irritating. You can see that the tail also is like incrementing in some way. And then we have an A here. So that's just really irritating, right? Like this county VTD field is going to be aggravating to work with because it's not in a standard format that corresponds to our shapefile. Our shapefile looks like this. So if we look at, say, the tail, oh, it does have it, but you can see here, it's now this one has a 2, 2, 5, 4. Like, what's going on,
right? And this one doesn't have a 2. 507. Like, what actually is that, right? So these don't correspond at all, which is just irritating. So I think we're going to have to use VTD key, which looks like it maps 1-to-1. So that's nice. Okay. So now we want to join these two things. And I wonder if I can just use another dplyr method. So if we say SF general election 2024 going to be equal to inner join. SF 2024 with EE 2024. Now we have some columns that have the same name but don't have the same value. This county VTD field. So I actually want to get rid of that. I don't want those columns because they're just going to make this updating. So I'm going to say select minus county VTD. Here I'm going to do the same. And then I'm going to say by equal. I think the correct syntax is now join by. Yep. VTD. I can't remember if that has to be quotes or not. I'm guessing not, actually, but we'll see. All right, that worked. So now let's look at the head of this file. And we can see here that we have vote totals, write-in, Trump, Oliver, Stein, Harris, and we have our geometry as well. So now we have the voting total by district. Well, we plot the whole district represented by their vote total. Okay. Now the question is, how would you want to visualize? Right? Want total voters? There are options as well. Now there is a file in here. I believe it's 1470. I thought it was 1472. Look at the office. Go down to 14 something. 14. What? One of these is the turnout. Okay, there's more than one. Okay, so 1428. County voter registration is 1429. So turnout is 1428. So if I look here, 1428, this is the voter turnout file. So what do we have here? We have the number of voter registrations, we have the turnout, we have Spanish surname voter registration. Spanish surname. Okay. I'm not sure why the state of Texas tracks that, but they do. So what do we want to do here? We should probably just get that turnout file. Say need turnout. Out path is the same. File is, what do we say, 1420.
So we might think about a way to generalize the reading of this file with a function that saves it as, I don't know. We're just thinking that we're going to probably want to generalize the files in a way that we pass the file name and it gets the file. Which is pretty straightforward. We don't need that. Not automate anything yet. Turnout. Here's our turnout. And voter registration. I guess voter registration is probably the total in the county, total registered voters in the district. And we have the Spanish surname. What else potentially useful to grab here? Statewide, not sure. Don't even have that. Okay. 1473 is Court of Appeals. So yeah, all right. So I can imagine that if we're creating a dashboard visualizer to look at the voting results on a per election basis, we would want to have a drop-down select something like what is the office. We can create that using this offices file where we just go down and say create a list of the office descriptions, and it'll like Gregg County, Justice of the Peace, Precinct 3, and you can select whichever office you want. And then we can use that office name as a lookup. So the office name looks into the office's file, pulls the number, and then the number goes and selects which file it needs to draw that map. Now the same thing can be done for the election, but I don't have an election list. So I think the thing I'll have to do is create a list of elections from these directory names and then save that in a file with the corresponding numbers underneath, right? I believe these numbers, prefixes, are all distinct to the election name. So that's just a file I'll have to, in order to create such a lookup, if we want to have, a neat little dashboard and look up any election. All right. So now what are we doing? We're going to want to plot the general election. But what do we actually plot? So usually you plot some sort of color by proportion of votes, and if there's more Republican votes, you color it red, and if there's more Democratic votes, you color it blue. So you could do that. Very standard plot. So we'll have to join our turnout data, vote totals data. So vote total data, SFGE. And call this. I actually don't like the order. We're kind of would prefer join turnout data with the voter total, the voter registration data, or the vote count data with the turnout data, and then join both geometry. It doesn't really, but maybe if we're doing a dashboard in that order. We already have the other file, but I need some more.
SF, shapefile, general election 2024 turnout. Energy. SF. Turnout 2020. County voter tabulation. File with annoying characters. For the column with annoying characters in it. Then we're going to say join by we're just going to look at the top and bottom and make sure our voter tabulation. Problematic. What? Dot dot dot. Bye. Dot 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 dot. ATD key 1 2 3 4 5 6 9,012. So that's the number of views that we expected. And if you notice, say head, it only gives us 6 features. It's kind of another way to check this would just be to print SF plus the total 9,000. One. This one gives me like, whereas I ran this one and it active. Expecting. But still one interesting. And so we have our turnout. Let's just plot turnout. Actually, let's do voter registration. We could do county level or we could do district. District level is certainly more interesting, but we haven't come up with a good way to plot it yet. We kind of need to be able to zoom in because the urban area voting tabulation districts are so close together. It makes it really difficult to analyze anything. So to start, let's just look at the county level stuff. This is a bit boring. So what going? County
SF 2020 turnout. We're gonna turnout. Summarize, right? So, summing over all the voting tabulation districts. And now if we go back, our simple, where we talked about geometrical operation, gave us some vocabulary. Constant, aggregate, and identity. They're different column types. And the voting, the turnout number is a constant over the spatial extent, right? The voting tabulation district has a constant for an election. The turnout is a specific number. It's a constant. And after we sum it up, for the county level, it becomes an aggregate, right? It's technically still a constant because we haven't normalized it to any value. But say if we normalized it, turned it into proportion, the voting turnout proportion, then it's actually aggregate. So let's do that. Because the total turnout is correlated with the population size. It's not that interesting. So we're going to look at the proportion of it. So turnout equals some turnout. And voters equals some voter. Notice also that turnout is capitalized. Voter registration. I normally don't like working with capital names in the columns, so in the summary table, I'm making it. And then we're gonna ungroup, and we're going to mutate a new column. A turnout option. Prop. Going to be turnout divided by. Cool. And then we're going to plot count. Yes. I want to plot it on the screen. This should be a quick operation. Interesting. It must have something to do with the shape. Sure, exactly. Plot. Where's my plot? It's did a 4 times thing. It did each one. We're back to this question. How do we actually only plot one of these? There must be a way. Okay, well, and nevertheless, right? Okay, so we see turnout, and clearly the sum of the turnout is just the population map. Same with the voters. And we look at the turnout proportion. I really don't like these colors. Very interesting choice of colors. Anyway, turnout proportion, right? So, you know what's really interesting is the correlation to the proximity Rio Grande, right? Like that's the really interesting. Why is turnout so low? I wonder if it's like that historically.
Maybe that's why they track Spanish surnames, right? Spanish surname turnout looks like exceedingly low. Okay. We also really see really low turnout just visually around Waco. Very interesting. Not sure why that would be. High black population in Waco. Interesting. But also like north of Houston. Bizarre. Like what's up there? Is that's like George Bush country. Interesting. I think George Bush lives over there somewhere. This purple county out here, north of Houston. It's somewhere over here. I'm not exactly sure. George W. Bush. The Bush family is basically their ranch is over there. I don't know if that has anything to do with it. Just surprising to me. But we can see that these counties along the Rio Grande are very low turnout, as are the agricultural communities in the Panhandle. Whereas certain other counties, probably like oil country, shows very high turnout. Very high turnout in the hill country, western hill country counties as well. Very interesting, very interesting. Okay. Well, I'd like to plot just that one. Let's do like select turnout crop and the actual plot that I want. Yeah, there it is. Wow. Almost like above 80% turnout in these super far stronghold counties. That's crazy. Actually crazy. And under 50% down in Brownsville. Oof. Yep. That's it is what it is. So we're already seeing some interesting information here. Like the turnout is very interesting. Turnout above 80% in Blanco and what is that, Comal County. Very, very high. Very, very high. I do wish I had the counting to figure out how to get them. It's going to be important at some point for good visualization. I would like to look at something at the voter district level. So something like voter turnout at the district level in a county, in a single county. That'd be. So how do I determine like which one is Travis? That of interest. How do I determine which? Like I need the name of the county. So what data set would have the name of the county? Wrong. Well, we have these offices, but we really need like county. Well, that would be ideal here. We don't have county name on any of these files. So we're gonna go back here and pull up the list of data sources and see if any of these might potentially have the county PD precinct. Related to district plan. Not interested in that too much. I need the names of the counties. 2010 census geography. I wonder if it's in. You have that. Geography. Yeah, good. This has that information, but this is just an informational the other files. So what is that? Where is that? No, 2010 census or 2020 census, 2020 census stuff. And it just has a single file here. Should be further files. Oh, I think we only downloaded the file. I have to adjust our set name. Yes. Okay, so we have shape files, lots of stuff. url.zip. X. So probably want to do something like download this. But so just yeah, etd root if get regular expression file size x x. I don't even. Uh, because I don't even know what it downloaded there. So, oh, there's file quickly. Um, and file path, not file path is quite a bit. Look, 24 general. Here, structure we were looking at before. Here, quite a bit. So, to collect this, is not going to work. It only works. Download data, hold state, create file name. File name. File URLs. Forgot from here, so this still works. We'll get all the URLs that match if it's else. Else what? Else. Match. Not the matches. create a regular expression that will pull file name and extension out of a URL like this. I want to have download and return it as a okay, the file name. Gonna do something like this. I can't parse arguments and pass them down. Ugh. More complicated. Okay, so to take arbitrary argument, pass it down a file name. We could actually only call this download, right? So that's kind of a so I think it's like arg list equals arg, something like that. Correct my strategy. List arg list. Getting past them all the way down. Triple bang arg list. Is that really? Bang arg list. File. Because we need file name. Arg list 1. this. Invalid argument. Have to specify a bit more how we're passing. Every element in file URL, pass that as a named element URL. Then we're going to do each of those, pass it the URL and the plugin. Oh no, we don't. The level up. Valid argument type. This okay. Um, valid download files. address. Another problem. Only. Higher level. And that's a bit of should be past this. Section. Beautiful. All right, might take a second. These census files can be big. So the problem we were running into is ChatGPT suggested us to use triple bang, which comes from a package called rlang, which is in the imports on this. And rlang is going to make it sort of alleviates the necessity of using this do call expression, but we can just as easily dot call and pass arglet. Seems to be working just fine. And what's happening is at the highest level function, this download dataset function, we now pass arbitrary parameters. And one of those arbitrary, well, the only arbitrary parameter is get v. So it passes it down, then saves that text, passes it to the download files function, tracks it, and it's only one element. So the first element here, and they really have to be ordered or named, but the first element here, I could put them. Well, we'll cross that bridge when we get. We extract it and put it in the create file name function. The create file name function then checks the value of get vtd true. It's not, so it downloads all the files instead of just the selection. So we got our 2020 census geography, and we can see it all here. Look at that. Amazing. Block groups, pop. What's in here? So census block. Shape length, shape area. So this stuff was extracted from a shape file, you can tell, because it has these letters. County block group. So block group does not correspond with voting. I guess county level data for that. What's in this? So here's our county shape file. So we have some ethnicity data, census tract, and the census block. Right, so one downside is we don't have census data for voting, which is probably why they track Hispanic surnames as the only proxy for census data. We only have census data at the county level and this sort of block group level, which doesn't really tell us much because it doesn't correspond to a voting district. So there's some statistical problems we run into if we just generalize the census information to all the voting, because where people live inside a county or a voting district is not evenly distributed. It's highly spatially correlated. They will not, voting districts, even if they have a certain county has a certain population, same. So we're going to have to think about how to handle that. Downloaded our data. Was the shape file. I don't think we actually need that because it can all be extrapolated. The county level stuff is the county level stuff. The shape files that we have. We don't have to worry about extracting the shape files. And we can just correlate cities pop, right? How are we going to daisy chain this data together? County ID tips county. We're going to have to join this county have it. We can think about simple linear models that might say something like, as a function of the county's demographic profile, how much of the variance in turnout proportion is explained. In other words, the turnout proportion varies fairly substantially, down to about 0.2 or 0.3 up to about 0.9 or even maybe higher. That's at the county level. So that's a big variance. That's a big distribution wide. And we also know that the county level demographics are quite varied. And the question is if any of this variance in turnout proportion across the counties can be explained by the demographic makeup. So do voting patterns across ethnicities at the county level explain what proportion of turnout do they explain? I mean, obviously, it doesn't take a genius to look at this map and see it explains quite a bit. But the interesting thing will be how to quantify that. And then we could do something like create a map that estimates turnout proportion as a function of demographic breakdown and see how well it reproduces the voting map that we did see. We can continue to add factors to that model and then try and reproduce a better and better voting map. Other things that we could consider are past demographics.
if a voting pattern of past election explains anything about the voting pattern of subsequent election. And this way we might be able to create a predictive model for voting patterns. Now the question will be, does such a model predict in the future what will happen, or is it really just a looking back model, identifying features that happened in the past and sort of in hindsight suggesting what will happen in the future? And there's no doubt that future elections will be beholden to trends that we have not yet observed. But I think the question also that is raised is, do those past behaviors explain anything of what happened in the subsequent election? And the answer there is very likely it explains something greater than 0. It doesn't explain all the variance, but it explains something greater than 0. And so if you can look particularly at elections between 2020 and 2024 and look at that voting data, and if any trends in that voting data explain what the voting patterns in the 2024 general election, then you could very likely apply those trends of voting pattern across ethnicities to subsequent elections. It will very likely hold. And so your model of the, say, 2028 election will become tighter and tighter as your ability to predict what will happen will become tighter as we get closer to the election based on the trends you see in the election leading up to that point. That's an interesting idea. So like the voting behavior in the 2016 general election explains some of the voting behavior we saw in the 2024 election. But how much? Some fraction. Not the whole thing. It explains some fraction. And some fraction of the voting behavior in the 2020 election explains the behavior in the 2024 election. Explain all of it, it explains some fraction. The question is how much of that fraction. Also be interesting, there's a lot of elections in this data set. So do any of these elections particularly well explain voting behavior in any other election? And those are very interesting questions. Then you can try and go back and look at those elections and understand historically why those things took place. All right. Well, I'm pretty hungry, so I think I'm going to take a break here and get some food. And I think we've made good progress. We've imported our data. The shape files communicate well. We didn't have to mess around with drivers or projections or anything like that. We plotted some data at the voting district level. Have that showing. Yep. Our voting district map of Texas. Very cool map. And we plotted some data after aggregating at the county level. Then we went and brought in the voting totals from the 2024 election and plotted turnout 2024 election on the map of Texas by county. So I think next time what we're going to want to do is bring in some of the census data and start exploring the possibility of making a model of the 2020 census data and how much of the variance does the 2020, how much of the variance of the by county 2024 voting turnout is explained by census data. That'll be pretty interesting. So thanks for watching, and see you next time.